Yeah. Are
Yeah,
you here? Yeah. Okay.
yeah,
Okay.
yeah. We will start, sir.
Yeah. No problem. Sir.
Very good morning to all the participants. I welcome you all for the phase two of AICT sponsored short-term training program on IoT and artificial intelligence for smart communication and networking. It is a very immense pleasure for me to run this STTP. Already we had a huge success in the phase one, where in those 6 days all the participants have given enjoyed the STTP and learned many new things from Internet of Things and artificial intelligence. I hope this phase two will be also a good learning patch for you all of you. Today's chief guest, as a very familiar person in Tamil Nadu and in IEEE field, uh, Professor Prashant R. Nair, who is currently working as an associate professor in Department of Computer Science Engineering in Amrita School of Engineering, Amrita Vishwa Vidyapeetham, deemed to be University, Coimbatore. He has having more than 20 years of teaching, research, mentoring, training, consultancy, and academic administrative experience. He has taught many academic programs in the universities in USA and Europe. Especially one of the main important university in USA, University of California, San Diego, and Sofia University, Bulgaria. He is a Erasmus Mundus Fellow. He has written 6 books and edited 2 books and written 1 book chapter, and he has over 50 publication in reputed journals which are indexed in Scopus and Web of Science. He has mentored students who have won the international and national competition like Smart India Hackathon, Rajasthan Hackathon, TCS Digital Twin Challenge, and represented India as a part of National Hackathon team for Singapore India Hackathon. He has been facilitated by our Honorable Prime Minister Sri Narendra Modi. He also been ranked as top innovation mentor in Atal Innovation Mission Tamil Nadu for Tamil Nadu region. He has been serving as chairman, vice chairman, and coordinator of Amirda deemed to be universities in various internal quality assurance cells. Apart from this, Professor Prashant R. Nair is a uh, volunteer, and he is one of a prominent member in IEEE India region and also IEEE Go region 10. I am very happy to invite you, sir. I request you to give. We are all waiting for your lecture. I request you to share the screen so that you can start.
Yeah. Yeah. Thank you very much, Dr. J.N. Swaminathan, and the management of QISCT for inviting me for the this online STTP of sponsored by AICTE. Incidentally, this is the second edition. The first edition was over, and I'm just repeating what I covered in the first edition. So basically, what I am going to do is I'm not going much into a research perspective. I will stick to the fundamentals to give you all the participants an overview of the concepts of IoT, that is in the morning, and in the afternoon session, 5G technologies and overview of IoT, 5G technologies. I'm very much familiar with the IoT landscape because of the fact that a lot of, as mentioned in my profile, we are working on a lot of innovations for various hackathons and competitions. That has become a very passion for me because, you know, even though I've been extremely busy with a lot of administrative roles in our university, which is India's #1 private university, and fourth ranked in the whole country. But at the same time, at times, because of administrative assignments, I have not been taking classes for many semesters in between. Now I make it a point to try to take some classes at least during my despite all the administrative activities. But I am now we are working a lot on hackathons, and especially IoT, digital twin hackathons and all. So most of the hackathon victories have got a base of IoT. Some cases we have even interfaced with mobile technologies, Android apps, not 5G per se, but you leverage the power of mobile apps also. And we have got a lot of good success, many hackathons. Almost, I would think I have 6 or 7 teams now. Maybe we would have participated in around 50 to 60, and at least in 80% of them, we have come in the top ranks, either victor or runners up or something like that. So we have been generally among the success this thing, and the hit rate has been very good. But let's hope that that continues. The competition has also increased a lot, especially in the hackathon landscape, because when we started participating in Smart India Hackathon in 2017, there were a few thousand teams. Now the teams, this 2020 Smart India Hackathon, I was told there are 4 lakh students, perhaps 1 lakh student teams have totally participated in this year's edition. It was a few thousand, maybe 7,000 or 10,000 4 years back. So the competition, the landscape has also really increased. So it's a good idea for, as faculty members, to work with your students, work with your peers, try for an interdisciplinary kind of orientation. You should think, look beyond your department. If you are in an electronics department, look towards computer science department, look towards mechanical department. Try to focus on projects that are interdisciplinary, that give you, which is very much the need of the hour. So I would strongly recommend that, each faculty members, please, look for good teams, try and, you start first year, you may not win anything. It's a learning curve for all of us, but once you move forward, slowly but surely you will get a lot of experience, and the more you participate, the likelihood of winning. So maybe first year you may try, you may not win. Second year you will get the formula right, and so on. So I will today's morning session, I'm just going to give you a overall an overview of the landscape of IoT. It is a very fundamental kind of presentation. Is my slide visible, Dr. Swaminathan? Is my slide visible?
Yes, sir, it is visible. It is visible. I request all the participants, kindly please pin Professor Prashant R. Nair presentation. Please, once again, I remind you, please pin Professor Prashant R. Nair presentation. And I request all please don't enable your audio or video. Okay, sir, you can start.
Yeah. So as mentioned, I will give you a quick overview of the landscape of technologies in the IoT or the Internet of Things. Basically, try to explain you what are the building blocks of IoT, and rather answer the question, why IoT? Why IoT, and what is the relevance in today's landscape in terms of technology? So the question of why IoT kind of answers with this slide that talks of the 4 generations or of the industrial revolution. So today many of us call these as Industry 4.0. It's a collective term that looks into the what is the industrial landscape today. So when you look into the evolution of the industrial revolution, maybe in the end of the 18th century, in the 1770s, Robert Watts and the steam engine started the trend of people going for automation, people going for machines that electromechanical kind of machines, which kind of resulted in factories being set up in the industrial revolution, so as to speak. It was primarily it was driven by the steam engine. The steam engine, the engine was the growth enabler for the industrial revolution, and subsequently factories started coming. The next major inflection point happened in the beginning of the 20th century. That is, in the 1920s, Henry Ford started this automobile revolution. He started producing automobiles in a mass scale in a factory. And because of the, at that point of time, we are talking of 1920s, almost a century ago, they were talking of having automobiles in millions. You can imagine Henry Ford made 1 million automobiles in the 1920s. So that was the second coming, or the second industrial revolution, wherein so the automobiles became spawned a lot of ancillary factories, ancillary industries, and the mass production started and became the norm. People started manufacturing. So the factories were all there. They were making items, products, but the scale was not there. And now we started having factories that were producing in mass numbers. Everybody's transitioned to factories that were in thousands and millions and so on. The third wave happened pretty recently, just 40-50 years back, which coincided with the microprocessor and the developments in microelectronics. As a result of microelectronics and the microprocessors, computing power started coming. And because of computing power, a lot of factories became smart. We started using electronics, electronic components, both active and passive. We started using computers. We started using microprocessors, microelectronics, PLCs, and so on. So this is the third wave of the the industrial revolution, Industry 3.0. So this trend started in the 1970s. And perhaps this trend is even now on to some extent, because till last year we were talking about the Moore's law. I'm sure you know about the Moore's law, that the number of active elements in a processor double every 12 to 18 months. So that was going on perhaps till the last year. Now I think people don't talk about Moore's law, because now Moore's law is no more relevant. That is what people are talking about. I'm talking of the cutting edge. Today Moore's law appears to be irrelevant, but even till last year people were talking about the Moore's law. So electronics and microelectronics advances have been really increasing in a very, very fast fashion. Now coming to today, the Industry 4.0, where the Industry 4.0, the building block of Industry 4.0 continues to be the cyber physical systems, IoT, which are enabled by IoT. And we have cutting edge technologies like IoT, machine learning, robotics, 5G. All of these are completely transforming today's industrial landscape, so as to speak. We are able to see this change in the, why this is not moving? So what is Industry 4.0? The term was coined in Germany, but there were similar things that were alluding, like smart manufacturing. In the US, maybe Industry 4.0 was talked about as smart manufacturing. Generally speaking, Industry 4.0 is a collective term for technologies and concepts of a value chain organizations where the building block is the cyber physical system. A cyber physical system is a system that is a combination of physical and computing based system that collaborate, communicate with humans and each other in real life. So, you know, if you are talking of, we are talking of smart factories, smart education, smart cities, smart transportation, smart cars. Everything is smart. So there are physical processes. There may be a factory which is making automobiles, cars. There are machinery, there are welding shop, there are fitting shop, turning shop. All those things are there. The physical factory is still there in the sense that there is still welding required, there is still manufacturing required, there is still mass customization required, there is still lean manufacturing required. But those machines have been now rendered very, very smart and fast. Smart, fast and precise. They have become intelligent. So the welding shop has become intelligent. The turning shop has become intelligent. The fitting shop has become intelligent. Effectively, the factory itself has become smart. The manufacturing has become smart because of Industry 4.0. So how is it becoming smart? It is because it has become a cyber physical system. The physical process of welding. So welding is a physical process. The welding is normally a welder was doing, taking the rod and welding with the help of the console. Now he need not do that. He can just go to the smart factory and give the instructions. When he gives the instructions, automatically the machine is able to weld with more precision and accuracy. So what is happening is the physical process is being monitored and there is a virtual copy of that physical process and it is going very effectively. So cyber physical systems which have enabled smart manufacturing and smart factories, basically there are a mix of both humans, devices, all intelligent. Humans are intelligent, devices are intelligent, the physical systems are intelligent, the virtual processes are intelligent, and all of them are collaborating between each other. So IoT and cyber physical system is the enabler for the smart factory, the Industry 4.0, the smart manufacturing. All these are the same. Smart manufacturing, smart factory, Industry 4.0, they generally mean the same. But what are they? They are cyber physical systems where humans and devices both are intelligent, both are collaborating among each other as well as with each other, amongst each other, so as to do. Now, how do you enable this smart factory? How do you enable this smart manufacturing? How do you enable these cyber physical systems? Well, these require some building blocks. Cyber physical systems are enabled through certain building blocks. Perhaps the most important building block is the Internet of Things, the IoT. So I want you to understand the relevance first before I go into the technology. We have today come to the Industry 4.0, the fourth industrial revolution, the era of the smart factory, the era of the smart manufacturing. How is it possible? It is happening because of cyber physical systems. And what are these cyber physical systems? They are systems where humans and machines and devices are collaborating, communicating, cooperating with each other, talking to each other, amongst each other, to bring the notion of the smart factory. And how is it happening? These cyber physical systems are enabled by some building blocks. These building blocks are, number one, and perhaps the most important, IoT, or Internet of Things, which we will be seeing now. The other building blocks include the sensors. We have sensors for anything and everything. Third building block is the machine learning. Machine learning algorithms, the intelligent, we need intelligent systems. How do they work? How do these systems become intelligent? How is the IoT enabled? It is because of algorithms in machine learning and heuristics in artificial intelligence and machine learning. If you ask me, AI and ML are more or less the same. AI is the artificial intelligence. The engine for artificial intelligence is the machine learning. Then, of course, robotics and 5G. So now, I've told you 5 major building blocks: Internet of Things, IoT, machine learning and AI, sensors, robotics, and finally 5G. So in my presentation today, now in the morning and in the afternoon, I will give you an overview of the landscape of technologies of IoT. What are the foundation of IoT? What are the protocols? What are the technologies? Some use cases. And in the afternoon, an overview of the technologies of 5G. What are the things in 5G? What are the technologies? How 5G is evolving. Even today, we are still not completely into 5G. We are still in a test bed stage, and all that we will be seeing. So my focus is on 2 out of the 5 building blocks of Industry 4.0 and cyber physical systems, IoT and 5G. The other building blocks are AI and ML, artificial intelligence and machine learning, sensors, and of course, robotics. Now, if you see the, again, stressing on the relevance in today's world, Industry 4.0, the relevance. If you see all these terms that I have put in this slide, very interesting to note that none of these things existed just 15 years ago. None of these technologies existed in 2006. Whether it is an iPhone or an iPad, a Kindle, a 4G network, a Uber taxi, an Airbnb home, an Android phone, an Oculus, Instagram, Snapchat, WhatsApp. Now, if you see in today's scenario, I think we are hooked big time to all of these. I use an iPhone. I have always been using an iPhone. So I am not, I can't talk much about Android, but people who have been using Android swear by Android. They cannot even dream of having another phone other than an Android. Can you live without a WhatsApp? Very difficult. Official meet, everything is happening on this thing. Can you live without a 4G network? Very difficult. When you are going anywhere in the world, you want to take a cab, you just think Uber. So none of these technologies were there. But today, these technologies have become so prominent. These technologies have become so rampant, so ubiquitous, so pervasive. We cannot even think of life without, not all, at least a few of these. We cannot think of a life where these technologies are not there. And today, the COVID pandemic has only accelerated this. Now, if you see the time to reach 100 million customers for many of these technologies, it is very surprising to see. The telephone took 75 years. The internet took 7 years to reach 100 million customers. Facebook took 4 years. Instagram took only 2 years to reach 100 million. The game Pokemon Go took 1 month to reach 100 million customers. I am telling you, today you have a killer app, a mobile app. In 1 day, or rather a few hours, it is not a big deal to reach 100 million customers. It has happened. It has happened. 100 million customers can happen in 1 day, in a single day. It is possible. And the COVID pandemic has obviously accelerated a digital transformation. Today we are, we are all talking to each other. You are sitting somewhere. Ideally, I would have wanted to come to Ongole to the college and given a talk. You would have also wanted to come, but you are sitting somewhere in probably your homes or maybe your offices. This is not going to change. This trend is going to continue. Dr. Swaminathan was talking about IEEE. Very interestingly, last 2 months back, the IEEE Region 10 Director, in 2021, an Indian is going to become the Director of the IEEE Asia Pacific region. He called me 2 months back and said that, I have an urgent thing. What will be our focus on 2021? I have a major panel discussion. Give me your inputs by tomorrow. Somehow you get it. It's very, very urgent. And we were deliberating. We had a couple of meetings. We were discussing with people. And the way forward was very interesting. How many conferences will IEEE conduct in a physical mode? We are IEEE, the professional body, is talking of a blended mode of conferences. Many conferences are going to be totally online even after the pandemic. Few conferences may be physical, or conferences may have a blend. Some sessions are physical, some sessions are online. You can go to the place, but you may be sitting in your hotel room and listening to the lectures. The professional body is thinking of moving on to blended mode. Many of you are taking classes in online mode. Perhaps in some states, at least this may go on till the middle of next year. So we are moving towards a blended mode of education. Many movies are they are not going for a theatrical release. They are going directly to over-the-top OTT platforms. Directly, the producer is making a movie, he immediately wants money, he is just selling it to an OTT platform. Finished, rather than going to the theater. This may again continue. Around 8 or 9 years back, I don't remember exactly which year, when the great Tamil actor Kamal Hassan thought of releasing Vishwarupam movie in directly to an OTT platform. I think perhaps it was 7 to 10 years back. Exact year I don't know. There was such a hue and cry. All the producers were against him. All the distributors were against him. Many of the technicians were against him. Many of the theater owners were against him. And he had to shelve that. Now today it has become a reality. Movies are going directly onto OTT platforms. And the pandemic has only accelerated this need for digital transformation. Pandemic has accelerated the need towards Industry 4.0, towards cyber physical systems. Everything has to be smart. Today, the entire landscape of supply chain management, manufacturing, logistics. Entire landscape is now a digital landscape. How to go completely digital? That is how the companies are talking about. So it is in that perspective, the relevance of these cutting edge technologies. As I mentioned before, the building blocks of Industry 4.0 or cyber physical systems or smart manufacturing, smart factory, IoT, 5G, artificial intelligence and machine learning, robotics, and of course sensors. These are the five, from my point of view, these are the five major building blocks. I already told you about Industry 4.0 is enabled as a result of cyber physical systems. Cyber physical systems are basically collaborating computational elements with which control physical entities. So there are physical and virtual entities, both are there. Physical entity could be a machine, could be a person, could be a device, it could be anything. But these physical entities are monitored, controlled, coordinated, integrated through computing and communication core. So the physical system is now having new capabilities for communication and computing, and there is collaboration. And how is it happening? The Industry 4.0 is based on cyber physical systems, and how is it happening? IoT, 5G, sensors, AI and ML, and robotics. These are the five building blocks for these cyber physical systems. So I already told you, the concept of the smart factory. This was today's factory and tomorrow's factory. Every workstation, so there is a workstation 1, 2, 3, and 4. Every workstation is intelligent. Every workstation is flexible. Every workstation is adaptable. Every workstation is decoupled. Every workstation is decentralized. But all of them are interconnected. They are able to talk to each other. They are able to collaborate with each other. They are able to have dialogue with each other. So because of cyber physical systems, the smart factory has got workstations that are independent, that are autonomous, that are flexible, that are collaborative, and whatnot. Now, coming to the major building block of the cyber physical system, the IoT. Now, the definition of IoT from a logical perspective is every physical and virtual thing in any environment can perceive and act. The physical device, the virtual device is able to perceive and act. Means it is able to learn, act, operate, and sense. The device is able to learn, act, operate, and sense. Now, what are these things? The things are people, the things are environment, the things are devices. So, IoT means every physical or virtual thing in any environment can perceive and act, can talk to each other, can learn, can act, can operate, can sense. They form a cognitive loop. Now, how is it happening? It is happening because of some AI. That is fine. We will not come to that now. But every device, every human being, every device, the environment also is able to learn, act, operate, and sense. There is a cognitive loop. And based on this cognitive loop, these kind of actions are possible. How is it happening? Well, IoT is happening where things, devices, people are able to learn, act, operate, and sense. They are able to collaborate, talk to each other, communicate with each other. How is it happening? Now we come to the building blocks of IoT. The learning happens because of the cloud. Everything is stored on a cloud, easily accessible. Any device you can access. You can take your mobile phone, access. You can take your iPad, you can access. You can take your computer, you can access. Tomorrow, you can take your watch. I have an Apple Watch. Using the Apple Watch, I can access the cloud in a limited fashion. These things are only going to become better and better. How is it sensing? There are sensors. For anything and everything, there are sensors. You want to monitor the air quality, there are air sensors. You want to monitor the pressure, there are pressure sensors. You want to monitor the odor, again air sensors. You want to monitor the data, there are sensors for that. How is it acting? It is acting because of devices called actuators. So, what I'm trying to tell you is that this cognitive loop of learning, acting, operating, sensing. Learning, operating, just 1 minute. Learning, acting, operating, sensing is enabled through the cloud because the storage is there. Enabled through the sensors, because of that it is able to sense things. Enabled because operated because of the hardware and software advances, and acting because of devices called actuators. So because of these actuators, sensors, cloud, and hardware and software advances, people, devices are able to perceive, are able to act. So these are the building blocks of IoT. I already told you IoT, 5G, AI and ML, robotics, sensors are the building blocks of cyber physical systems and Industry 4.0. The building blocks of IoT are sensors, cloud, actuators, and of course hardware and software. Now, how did IoT come about? IoT started as a result developed from what is known as machine-to-machine evolution. We had peer-to-peer computing. We had peer-to-peer computing. We had machine-to-machine interaction. The machine was connected to each other, networked with each other, and they were able to share content. Peer-to-peer, machine-to-machine. But there, you could only have connectivity and content. So the machine-to-machines were interacting, they were able to share content and they were connected to each other. This evolved into IoT. Now in IoT, there are many more things. It is not only the connectivity and the content. Please understand, initially they were machine and to machine. Machine and machine were talking to each other. Right? Machine to machine were talking to each other. There was only connectivity and content. Coming to IoT, we had many more things. We have another, the cloud, the storage. We have the collaboration. It is just not sharing files, but there is a huge amount of collaboration. There is a dialogue, a two-way communication. There is a context. A context. There is a cognition. Cognition means analytics. You are able to think, perceive. You are able to analyze. You are able to take decisions. So, machine to machine is the precursor to IoT. Machine to machine had connectivity and content. Machines were connected to each other. They were able to share content. But when we came to IoT, when we transformed to IoT, we had a whole lot of more things. We had collaboration. People are able to talk to each other. Not only share, they are able to take decisions together. We had the cloud, lot of storage. We had the context, the situation, the ambience, and we had the cognition. The cognition where we are able to take decisions based on the data. The semantics are there, and based on that. So IoT is a huge jump over the machine to machine, the M to M, because it added cloud, collaboration, context, and cognition to the connectivity and to the content. And if you see this diagram, you will get a feel of what is happening. Right? You'll get an idea of what is happening. How the interaction is there. From machine to machine collaboration, peer-to-peer thing. Now you have machines, all are connected to each other through the cloud. Everybody is connected to each other to the cloud. I already told you about why we need IoT and the relevance. Now, coming to what could be the things in the internet. The things are many. The things could be devices, any device, computers, sensors, people, fridges, televisions, vehicles, mobile phone, clothes, spectacles, food, medicine, books. It is not anymore Internet of Things. It is Internet of everything. If you see the list, it is not only Internet of Things, it is the Internet of everything. Everything is now part of this. Everything is part of this. Internet of everything. Anything and everything is it can be made intelligent. It can be your clothes, it can be your shoes, it can be your belt, it can be your spectacles, it can be your watch, personal, people. It can be machines, it can be your fridge, your air conditioner, your television, your car, your mobile phone, your laptop, your iPad. So now, today, if you ask me, Internet of Things has become Internet of everything. That is the kind of transition that we are now seeing. Internet of Things has moved to Internet of everything. Today, you can imagine this number may be a little off because of this was written before the COVID pandemic. We are estimating that 37 billion things are there intelligent on the today. Okay, I have covered all these things. Yeah. So there are, if you see the number of devices that are there, the numbers are very interesting today. Today we are looking at a population of close to 8 billion people. And the forecast was around, they are having something like 50 billion devices. Maybe because of the pandemic, this 50 would have increased. So we are talking of 50 billion devices and 7.8 billion people. So we are looking at around 6 devices per person. Can imagine 6 things online per person. Already you have maybe a couple of mobile phones, you have a computer, you have a laptop, you have an iPad, that you have 2 phones, 1 iPad, 1 computer, 1 desktop, 5, already 5 are there. So of course some people may not have that many, some people have many more also, but we are looking at 50 billion smart devices for a population of 8 billion souls, meaning that each person today, as on today, has 6 intelligent things. You can imagine the impact that we are going to see. This number may have only accelerated because of the COVID pandemic. As I mentioned, it is IoT. IoT has moved to Internet of Everything. Internet of Everything. From Internet of Things, it has now moved to Internet of Everything. Every single industry or vertical is now impacted. Smart hospitals, smart banks, smart insurance companies, smart facilities, smart cities, smart shops, smart supermarkets, smart manufacturing, smart cities, smart buses, smart cars, smart logistics, smart regulators, smart consumers. Every vertical has been, so as to speak, impacted by the power of IoT. Healthcare, media, logistics, transportation, manufacturing, energy, retail, building. Now, coming to the, so I have given the context of IoT, where I mentioned you that IoT is the most important building block of cyber physical systems, which enables Industry 4.0, with the other blocks being 5G, the other blocks being robotics, 5G, sensors, and machine learning and IoT and artificial intelligence. I also told you that how is IoT happening? Devices, things, not devices and things, everything. Everything can be made intelligent. It can be your spectacles, your clothes, your shoes, your medicine, your food, your car, your bus, your phone, your laptop, anything can be intelligent. And how is it happening? You have devices like sensors, actuators, cloud, making this happen. Now, coming to the basic IEEE definition of IoT, IEEE describes IoT as a network of items, each embedded with sensors which are connected to the internet. Of course, this is a very, it's a rudimentary definition, but this is the definition of IoT. So I already covered all these things. If you recall, I told you that today the population is 7.83 billion people today's world, and there are 50 billion smart items, 6 smart devices per human being. Now, one step ahead, I'm looking. In a car itself, you can have so many sensors. You can have so many sensors in a car to monitor a whole bunch of things inside a car also. Now I'm coming to the protocol stack of IoT. The protocol stack of IoT, the reference model. So we have learned about the 7-layer model of the network, the ISO OSI level layers, open system interconnection layer. We know we start with the physical layer, go to the presentation layer, the network layer, transport layer, session layer, presentation layer, application layer. I'm sure you remember about that. The ISO OSI model, starting from the application layer, application layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. That is the 7 levels of this thing. IoT has its own protocol stack. At the lowest level, you have the physical layer consisting of the physical devices and the controllers. The things in the IoT, it can be your computer, it can be your laptop, it can be the sensor, it can be anything. It can be your refrigerator, it can be anything. At the data link layer, you have the processing and the communication units, the actuators, the intelligent devices, the intelligence of these devices that make them intelligent, maybe the processor or the communication units and so on. That is the data link layer. Here, the network layer is, instead of the network layer, we have the edge computing, the fog computing, the cloud layer, where the data elements are stored, cleaned up and collated and so on. Then you have in the transport layer, here you have, instead of transport layer, you have the data accumulation, the storage. You have the cloud where all these things are kept with protocols, with security, which can be easily accessed by anybody. Here, instead of the session layer, you have the abstraction layer. Here, the abstraction layer is, see, this IoT has resulted in a big data. So much of data is there. A car will have 4 sensors. If the car has 4 sensors, the car may be generating a lot of data. So much of big data is there. We'll come to that big data a little later. But how do we clean up this data? How do we aggregate the data? How do we store the data? How do we make the data in a format that everybody can use? That is the abstraction layer. Then you have the application layer, where you have the analytics and all. So once you have this big data, you got the data, you cleaned up the data, you put it in a format, you made the data from an unstructured format to a structured data. Now what do? You have to mine the data, analyze the data, look for insights. And that is the application layer here, which is equal to the presentation in the ISO OSI. And on the top, you have the collaboration. So this is a 7-layer protocol stack for IoT, starting from physical devices, moving on to connectivity, moving on to edge computing or fog computing, moving on to cloud and accumulation storage, then to data abstraction and pre-processing, then to data analytics, and finally to collaboration. So it's a whole new protocol stack. So entirely new protocol stack for the IoT. And you also have communication technologies for IoT. IoT will not be useful unless you have very good communication technologies. And we are going to see the 5G technology in the afternoon. But IoT also requires a whole lot of other technologies, RFID, Wi-Fi, 5G, PLC, near field NFC, Zigbee, Bluetooth. All these are very much needed for communication technologies. And of course, the internet also. Yeah, this is just a slide on what is the difference between a wireless sensor network and IoT. In IoT, all the sensors directly send their information to the internet, but in wireless sensor network doesn't go to the internet. They may be just talking to each other. They may be sharing to some central router or some node. That is a basic difference. And I already told you these things. Okay, now let us see some, some interesting use cases of IoT. Just some futuristic. Yeah, with this I will close actually. 1 minute, just give me a minute. No, there is a little more to be covered. Just some smart use cases for IoT. We will just see. Then I'll just touch upon big data before I wind up. Now, today, even though COVID pandemic has resulted in a lot of online e-commerce and shopping and so on, there's no doubt about it. But having said that, IoT has a lot of application in smart retail. Now, we may continue to buy a whole lot of items online. I don't deny that. But at the same time, going to a mall, going to a supermarket, going for shopping. I'm not talking women alone, ladies, even men. The experience of shopping, going to a mall, is also, having its own benefits. See, I may not go to the Brookfields Mall. If I'm before the pandemic, perhaps I used to go every month to the mall. I may buy, maybe I go twice a month to the mall. Once I may make a perfume purchase of a Dolce & Gabbana perfume. Maybe another 3 or 4 trips, I may not buy anything. But still, going to the mall has its own, experience. Going to the supermarket, going to the hypermarket. But can you add value to that experience? When you are walking across the aisle, you have messages coming to your devices. From the goods, the products are telling, I'm here. There is a sale. I am detergent 2340 and I just came yesterday. I am a fresh stock. Excuse me. I'm a fresh stock. I'm a new stock. So these kind of things can be there. And you want to have, an experience of less contact. You go to the shop, you buy the item. Ideally, you don't want to make any payment. You just walk in the supermarket. Automatically, your payment will happen. Already, your car, you're moving through a toll gate. The fast tag takes care of the electronic toll payment. Automatically, the money is taken from your account. So we are going into a new retail experience. So people will continue, once the pandemic is more or less contained, definitely people will go to malls. And can we have intelligent malls? Intelligent malls where the products are talking to each other. They are to you. They are introducing to you. You are not going to pay anything. You are just going to walk. You are going to give all your items, put the items in the cart, put it, scan it. Automatically your bank account will be thinking, because already you are registered and so on. So IoT can make a huge difference in shopping. Healthcare. Your body may be full of sensors. If you are a heart patient, already there is a sensor. While you are simply sitting and watching television, your doctor will know whether there is an ECG variation. There will be a sensor that gives live feed about your heart condition, and when there is a problem, when there is a variation, when there is an issue, the doctor will know and the doctor will call you. There is a problem, come to the hospital. Like that, your body can have several sensors. Already there are, for insulin patients, there are already many devices that have come. Glaucoma sensors, retinal sensors, cochlear sensors for people who are having hearing problems, hearing aids. So smart health possibilities are, actually speaking, endless. Diabetes. I'm actually borderline diabetic. I'm not diabetic, but I'm borderline. If I have a device, I actually got this diabetes. It's not at all a hereditary problem. I used to drink a lot of Coke. I mean, living in the US for some time, I got into a bad habit. Last almost 20 out of the 20 years, the last 15 years, every day I would have 1 or 2 cans of Coke. It's a very, very bad habit. See, I got addicted to it and started carrying on the lifestyle, and I became borderline diabetic. Now, if I have a device, it's not very difficult, it's very easy to throw the bad habit in one day. But slowly I started controlling. Twice in a day, it became once in a day. Then I made it once in a week. Now once in a month. Now last 6 or 7 months, I've not gone out of my apartment. I'm a campus. I've not drunk a good. Last month, I went out for something. I had one Coke. But if I have some app that will tell me my sugar level, accordingly, maybe I can indulge in my bad habit. Because if I am able to monitor my diabetes, my sugar level, maybe I can think. Now, you think twice before you drink a Coke or you have a sweet. Oh, maybe, I shouldn't get into diabetes, then insulin, and it will be a major problem. So, if I have smart apps, that can help me. What else? If I have a small sensor that will connect to my smart app, what better than that? So, everywhere and anywhere, you can have these kind of devices. IoT devices can be there in smart health, smart retail, smart home. You can be sitting in California and you can control the temperature of your ancestral house here in Coimbatore. It is possible. You can be sitting anywhere in the world and you can control the speed of the air conditioner, the refrigerator, the appliances in the house. So the possibilities are endless. You have cars, smart cars. Smart cars will be adaptive. You have sensors for fatigue. If a driver is drowsy. In fact, one of my students, we won one hackathon called the TCS Engine X Digital Twin Challenge. So basic model is that lorry truck drivers become drowsy. They drive for 18 hours, 16 hours with very few breaks. If you have a sensor that can look for drowsiness, sensors for mood, fatigue, monitoring from the images, nothing like it. If the company knows, oh, that guy is getting, then he can be given a call. Hey, dude, you're feeling sleepy. Please stop. Have a tea. Take some rest. Then you drive. These kind of things can reduce accidents. Smart cars, smart transportation system, smart lorries, smart trucks. So the context is really good. Now, already the car is now very intelligent. Already there are 30 to 90 processors with the car. This number is only going to increase. Processor means for the fluid, braking fluid, for the engine control, for the airbag, for the windshield. There are many processors or sensors or whatever actuators, but we can dramatically increase this and make driving a very safe thing. Monitoring the environment, weather conditions, temperatures. Now, since many of you are faculty members, I will give you the links of some resources which you can use to train your students. There is a very good platform for IoT based projects called ThinkSpeak. It is just ThinkSpeak. Thinkspeak.com. There are a lot of good exercises and projects are there for IoT. It is free and open source, but after 2 or 3 months, I think you have to pay. But what you can do is you can always use a different email ID or a different registration and get this projects. They're very, very good projects. We have used this ThinkSpeak in our IoT electives as exercises. So this is a very good resource that you can use. It's very easy. ThinkSpeak. Thinkspeak.com, and you can actually add widgets, get visualizations, tweak with the data. You can have some sort of remote triggering, remote controlling, remote monitoring of IoT, but it will take some time. You can do the temperature sensor demo, you can do pressure sensor, air sensor. So many things are possible. So I will strongly recommend that for training your students, you can use thinkspeak.com. Another resource that I feel that you can use is that you can go for the Intel IoT resources. Intel IoT resources are very, very beneficial, very, very effective and efficient. And in fact, if you are going for Intel IoT resources, you can also, there are some sort of free certifications, in the sense that you do some IoT projects using the Intel resources, you can become an Intel certified, what is that, instructor, something. There are some levels, I exactly don't know. But I will strongly recommend to use this ThinkSpeak and Intel IoT resources, which you can just Google and find out, to find about various projects and technologies that you can use for your students. Now, coming to the last aspect, the biggest and the major challenge in IoT. Of course, there are many challenges: security, privacy, interoperability. Interoperability means you are in a 4G network. How can you connect to a 5G network? Can you connect to a 3G network? You are using Intel IoT devices. Can you connect to some Android phone? Can an iPhone, Apple iOS be operable with an with some sort of Intel IoT resources? These issues are there. Then upgrading of technologies. How quickly technologies are getting upgraded? What are the insights that you get? So there are a lot of challenges per se. However, having said that, probably the biggest challenge, in addition to security, privacy, interoperability, standardization, is the challenge that we know of the big data. Big data becomes a huge challenge, because now we are sitting on a huge minefield of data. If a car has got 200 sensors, every day the car is generating 4 terabytes of data. If an aircraft has got 6,000 sensors, it is generating 2.5 terabytes of data, one aircraft. So we are now going to have a huge challenge of data, because so much of data is there. I told you, there are 50 million, there are 7.83 billion population. Each of them have approximately 6 devices. We are talking of 50 billion smart devices, intelligent devices. You can imagine how much of data is being used. Facebook has got 2 billion users. Even if you have 200 million people posting every day, you can imagine how much of data is there. So, biggest challenge that IoT is facing is the challenge of the big data. And with big data, if IoT has to be effective, we have to move to an era of analytics. Same thing I told you, analytics. Every day there could be 12 plus terabytes of people tweeting on Twitter. There are 100 different formats and of data. Every second, 5+ million online purchases are happening. Maybe this number is much more now. Huge velocity, huge volume, huge variety, and huge veracity. Veracity means, is it trustable? Is it proper trustable? See, you cannot give an assignment to your students looking at Wikipedia. Wikipedia is open source. Anybody and everybody can add on to Wikipedia. So the veracity is on question. You can give an assignment based on an IEEE paper. You can't just give an assignment, look into Wikipedia and write this assignment. That is not proper, because the veracity has to be checked. So IoT has resulted in big data. Big data is a huge challenge. And because of this challenge of big data, we absolutely need, we are grappled with volume of data, velocity of data, variety of data, and veracity of data, the 4 V's. So we need to do analytics. We need to analyze. We need to get actionable insights. We need to convert, this is my own understanding. You need to convert the data, the big data into information, and the information into knowledge, and the knowledge into intelligence. I hope, I'm just not playing with the words. I'll again repeat. You move from the data to information. I'm sure you know the difference between data and information. You need to move from the information to knowledge. Means you need to make the unstructured information into structure, that is knowledge. And from the knowledge, you need to move to intelligence, where we are able to use this knowledge for our benefit. So, because of this big data, we need to move from the data to information, information to knowledge, knowledge to intelligence. And when this intelligence comes, you are able to do analytics. So IoT's biggest challenge is how to grapple with this big data, how to analyze the data, how to clean the data, how to use the data. I've already told you this. How to identify the data, how to acquire the data, how to extract the data, how to validate the data, how to clean the data, how to do pre-processing, how to aggregate the data, how to analyze the data, how to visualize the data. There's a huge lot of challenges because you want to convert the data into information, the information into knowledge, and the knowledge into intelligence. And this intelligence means you want to take insights from the data so that you can make decisions. And that is a whole challenge. Getting the data, identifying the data, acquiring the data, cleaning up the data, pre-processing, because the data will be in so many different formats. It will be unstructured, making the data into structured fashion, extracting the data, analyzing the data, validating the data, visualizing the data, analyzing the data. This is going to be the biggest challenge of IoT. I will end my this thing with two case studies of smart of IoT being used with analytics. This is Clipfolio. It is a sample of a marketing dashboard. This is a drill down or a dashboard of some marketing product. Now, if you see, you can find out the complete data is here. You have 6,504 leads marketing. Leads means people who may convert and become a buyer of a product. Out of them, you feel 2,102 are more sales ready. Out of them, 307 are new customers. How much money you have got till now? $375,000. How did you do this? You had a massive social media campaign. You had 22,000 followers on Twitter, 13,000 followers on Facebook, 4,200 on Google+, 11,000 on LinkedIn, and you are also sending emails to prospective customers. So this is a complete dashboard, a complete drill down where you know exactly where you stand. So the IoT has to be supported by the analytics. Only then you can convert the data into information, information into knowledge, and the knowledge into intelligence. Another example, the Fitbit, and some of you might be having this on your mobile phones, where you are able to track how many your walking pattern, how many steps you took, how many floors you sing, how many miles, how many calories you burned, and you can monitor your health. But this is a complete dashboard where the IoT, the sensor, is all supported with the analytics. I think that's all. Yeah, this is the same thing. That's all from my side. I'll close with this presentation. I'll be happy to answer any questions. I pass this thing. Either you can put in the chat box, or I leave somebody from the organizers to moderate.
Sir, thank you so much. It's really a very good presentation. I request participants You can post your question in the chat box so that sir can answer your queries. I request participants, please answer you, ask questions. You are encouraged to ask questions. There has been around a half an hour time is there has been allotted for this. Please kindly ask questions so that you will be given a chance.
Meanwhile, before you are thinking of the questions, I have put the two resources that you can use for doing projects for your students. ThinkSpeak IoT project. Just Google, you will find out. ThinkSpeak.com is the website. Then, as far as course material and e-resources for IoT, the best resources that I have encountered, which we have used effectively for our hackathons and all, is the Intel IoT. You just Google and you'll find out. I have also shared my email ID in the chat box. Thank you.
Yes, participants, please ask your queries in the chat box. Any free tools are available to do simple projects in IoT?
Yeah, that's what that is what I have mentioned. ThinkSpeak will give you ThinkSpeak.com. It's the best that I've been using the ThinkSpeak for our students, and Intel IoT also has got some e-resources. These are the two things that I am aware of. But ThinkSpeak will require you to master. It's not so easy. You will have to try out and work out, and then only it's not very easy. You can't just plug and play. You have to download and understand the toolbox, try out some exercises, and so on.
Thank you, sir. Thank you, Rajendran, sir. I think your query resolved.
Yeah.
Any more queries, please? The Manoj Jadhav sir asked, sir, skills required to get job in IoT. What are the skills required?
Okay, it's a combination of hardware and software skills, and especially interfacing. Because see, generally speaking, people know about programming and all. Everybody learns programming, but everybody does not learn how to interface, use an Arduino board, a Raspberry Pi. So probably because I'm assuming that everybody knows programming. I mean, whatever be the engineer, whether he's an electronics engineer or an electrical engineer or a computer science engineer or an IT engineer, some sort of programming is known. It may be C or C++, Java, Python. So assuming that the programming knowledge is there, the ideal way is to go for Arduino board and Raspberry Pi. Do basic interfacing, learn how to do some basic interfacing of Raspberry Pi and Arduino board. I think that will help you to get a job. In fact, interestingly, in our university, Amrita Vishwavidyapidam, in the first year itself, we are having a computer hardware lab. Here we are, it's actually, it is only meant for, I think it is meant for ECE. I think it is meant for all batches. I'm not sure. I'm not very sure. But it is there. No, it is meant for all CSE, computer science, ECE, and all students have to compulsorily take this lab. So in this hardware lab, what is actually happening is you are doing some, assembling a computer, de-assembling a computer, doing some basic Arduino board programming, doing some basic exercises in Raspberry Pi. So based on this, you will you are very skilled in those things. So any job you do, you have the interfacing skill, you have the hardware skill, you have the programming skill. So these are, I feel, are the most important thing for an IoT job. But then if you are looking at a research level, means not physical IoT and all, you are looking at a research level, there is a lot of jobs and scope in data science, because as I mentioned, IoT has resulted in big data. A lot of big data is there. So we need better algorithms, better heuristics, better machine learning techniques, heuristics, algorithms to analyze and see. So there is a lot of work going on in data science also to make better algorithms, smarter algorithms. Even today we are using neural networks, CNN, and what is that? Genetic algorithms. We are using support vector machines, clustering, classification. We need to have better deep learning and better machine learning tools. There also a lot of skill sets are needed.
Thank you, Prashant sir. Anybody, any queries, please?
I don't think there are any more queries. You can even come online and ask. I'm perfectly okay. There is enough time. No hurry. You're also welcome to come online and ask a question. That's what I'm trying to tell you.
Okay, last call. Any query is there? Last call. Professor Prashant, sorry, I was having another CAC meeting. That's why my
No problem, no problem.
colleague, Dr. Lakshmi has just moderated.
Yeah, no
It's
problem.
as an opening batsman, you always done a very fantastic job. It's really once again a nice presentation. I'm sure faculties and scholars, research scholars will be useful for the ideas which you have shared. I hope it is very useful for all the peoples. Thank you so much. And I request participants, if you have any queries, you can also, there is a raise hand option which has been added in the Google Meet. You can raise your hand so that the questions, we will give you a chance in audio mode also. This is a last call for the queries. Otherwise, we can wrap it up. Yeah, thank you so much. Sir, I think so there is no queries. Thank you so much for your excellent presentation. Once again, we are waiting towards for your afternoon presentation 2 to 4. Dear participants, the link is same. Anyway, I will intimate you both via mail and WhatsApp. Kindly be on time. Once again, I want to tell this is an AICTE sponsored short-term training program. So 80% of attendance is must. Okay. Thank you so much, sir. The session is over.
Thank you.
Thank you. Yeah.
Thank you very much.
Yeah.